Hey guys, so now we're going to talk about the different counting rules, specifically permutations and combinations. Alright, so the fundamental counting rule, also called the fundamental counting principle, is you take each of the events, and then you multiply them. So for example, a coin is tossed, and then the dice is rolled. Alright, so you can get a head on a coin, a tail on a coin, and then the dice you can get 1, 2, 3, 4, 5, 6. Six. And so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. Okay, that's if we did a tree diagram. If we did the fundamental counting principle, then there are 2 choices on the coin, heads or tails. There are 6 choices on the dice, 1, 2, 3, 4, 5, 6. And then 2 times 6 is 12. Alright, so let's expand it to some bigger stuff. The paint manufacturer wants to sell several kinds of paint. How many different... Oh my goodness, so sorry. It's like in the middle of the day, too. Because it's chilly outside, I'm warm in my house, and Netflix, snuggle up kind of day. Alright, totally focused now. Okay, so they want to know how many different kinds of paint you can have if you have just, this should say 1 color, 1 type, 1 texture, and 1 use. So there are 1, 2, 3, 4, 5, 6, 7 of these guys. 1, 2, 3 of these guys. 2 of those guys, and 2 of those guys. That's a huge tree diagram if we have to make one. Or we could do 7 times 3 times 2 times 2. I'm going to stick it in my calculator. We get 84. Different kinds of paint. All right. Let's do another one. The first year, the state of Pennsylvania issued railroad memorial licenses plates, and the plates had a picture of a steam engine with 4 digits. 4. Assuming repetitions are allowed, how many railroad plates could you do? All right, so the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there are 10 different numbers. The number 10 combines those 2 symbols. So the different digits you can pick, there are 10 different ones, 0 through 9. So in this first choice, we have 10. Second choice, we have 10. The third choice, we have 10. And the fourth choice, we have 10. So we have 10,000 choices. Let's do it like if you can't repeat. All right, 1, 2, 4. All right, so we have 10 choices here, but now we've lost one. And then we have 9 choices there, but we lost one. And then we have 8 choices, but we lose one. So it's 10 times 9 times 8 times 7. And we get 50, 40 different plates. And so that's why they let you repeat letters and numbers, because there's so many more choices. All right, factorial notation just means you take that number, n, it's just a random number, and then you go n times 1 less than n, times 2 less than n, times 3 less than n, all the way to you get to 1. And then it's important to remember that 0 factorial is equal to the number 1. So for example, a problem that you would use factorial notation on is, how many different ways can you watch your favorite 3 movies? 2, 3. And so you want movie 1 and movie 2 and movie 3. So that's why it's multiplication. And so here we have 3 choices, and we've watched that movie. So now we only have 2 choices, and we've watched that movie. And so now we only have 1 choice. So that's the same as 3 factorial. Okay, 3 factorial happens to be 6, but we're going to get some really big numbers. We're going to have to do, I don't know, 10 factorial or whatever. And so I want to show you, I don't know how to do it. Hang on, I'll push the button with my finger. All right. So 3, then go to math, and then go over there to probability. All right, and then number 4 is factorial until we get 6. All right, so let's go ahead and use that concept of factorial in just a second. The business owner has 6 choices of locations to do her business, and she ranks each one, price, parking, blah, blah, blah. How many different ways can she rank the 5 locations? All right, so her first, she has 5 choices to pick from, and then she's picked that one. So then she has 4 choices to pick from, then she's picked. So now she only has 3 left, and 2 left, and 1 left. That's the same as saying 5 factorial. All right, 5. Go down to probability. So you get 120. And you can do it by hand if you want, but we're going to get some big numbers, like not just 5. All right, now suppose she's only going to rank her top 3 of them. So here she's got 5, then she's got 4, and then she's got 3. And so we get 60. You can't do 5 factorial because you'll get 120. You need to do just 5 times 4 times 3, your calculator. Here, 1 second. Just want to check one thing. All right, just FYI, this is called a permutation. We'll get to that later. I'm just kind of reminding, just kind of putting in that in your brain. Permutation. I don't know what happened. My U just disappeared. All right, and here we are. Permutations. So a permutation is where you're ordering some objects, but the order doesn't matter. I mean, sorry, totally said that wrong. But the order matters. So for example, a combination lock, like on your locker, or like when you lock your bike up or something like that, that should not be named a combination lock, because we're going to learn later that a combination, your order doesn't matter, but a permutation, it totally matters. So for example, if we had 3 letters, ABC, if order matters, ABC is not the same as CBA. Those are not the same. When order doesn't matter, then those two are the exact same because it doesn't matter what order those come in. All right, and so I'm going to do this guy right here, and then I'm going to do the one above it. There is a formula. I'm going to kind of ignore the formula because this is a short course, and I'm going to show you how to do it on the calculator, and then kind of like a shortcut way. And you can choose which of those 2 ways you want to focus on, but I want to give you 2 paths to get the correct answer. All right, so a talk show host can select 3 of the 6 for his program, and order is important, so that's how we know it's permutation. How many different ways can it be done? All right, so I put 3 blanks, And then this we have 6 to choose from, then we have 5 to choose from, then we have 4 to choose from. Okay, and we get 120. All right, now I'm going to show you how to do it on the calculator. All right, this first number is always the total number. It's the bigger number. And then the second number is the smaller number, like how many you're choosing. So let's choose 3. So we're going to write 6. Then we're going to go to, uh-oh, kidding. Okay, there we are. 6. Then we're going to go over there to probability, and then that P, because we're in permutation. And then we're going to write 3, not 6. Right, it's hard to do it like backwards. And 3. So 6, 2, 3 for permutation, and it tells us 120, which is exactly what we got. So I went to math. Math is right here, and then I went probability, and so that one's permutation, and that one's combination. And so 120. This 6 choose 3 for permutation. That's the exact same as if like this word problem. Let's look at that. So a school director can select 2 musical plays to present the next year. One is in the fall, one is in the spring. So this sentence tells us that order matters. And she has 9 to pick from. So 9 is the bigger number. Permutation 2. And we can do it one of 2 ways. So we want to choose 2. And we have 9 to choose from, and then we have 8 to choose from. So there are 72 ways, different possibilities. Or we can do 9 permutation 2, and we get 72. And remember, I went to math, and then I went over to probability, and then number 2. Right? And so it's 72 different possibilities. Okay, I'm going to stop this video because this is a longer problem, and I want to start the next video with this.